Om Shri Mahaperiva Sharanam. In our last class, we were discussing questions from class 9 NCERT Exemplar book from the chapter Surface Areas and Volumes. So we'll be continuing that today. We were discussing short answer questions with reasoning. Write true or false and justify your answer in each of the following questions. Okay. The first question. The volume of a sphere is equal to 2/3 the volume of a cylinder whose height and diameter are equal to the diameter of the sphere. Okay. How do we do this? This is Vs, volume of the sphere. So we know volume of a sphere equals 4/3 pi r cube. And this is Vc, volume of a cylinder, which is equal to pi r square h. Now, according to the question, the volume of a sphere is equal to 2/3 the volume of a cylinder whose height and diameter are equal to the diameter of the sphere. So here, if the diameter of the cylinder is equal to the diameter of the sphere, then this r will remain. If diameter is same, radius will also be same. So r square remains r square. What about the height? The height of the cylinder is equal to the diameter of the sphere. So the height will be, since it's equal to the diameter, it will be 2r, right? Twice the radius. So in that case, this equals, pi will remain pi, r square into r is r cube, 2 will come here. So 2 pi r cube. Now, they say the volume of a sphere is equal to 2/3 the volume of a cylinder, right? Let's see. Let's see if 4/3 pi r cube is equal to 2/3 of 2 pi r cube. Okay. Is it equal? Yes, because 2 into 2, 4/3 pi r cube. So, the statement is true. Next question. If the radius of a right circular cone is halved and height is doubled, then the volume will remain unchanged. So we have to see if this is true or false. How do we see that? The volume of a cone will be equal to 1/3 pi r square h. Now, according to the question, radius is halved. So the new volume will be 1/3 pi. Instead of r, it will be r by 2 square. Instead of h, it will be 2h. So we get 1/3 pi into r square upon 4 into 2h. This 2 and this 4 will get cancelled. So 2 2s are 4. This is equal to half. This 1/2 will come here. Half of 1/3 pi r square h. Do you get this? The old volume was 1/3 pi r square h. Now with this we have the new volume as half of 1/3 pi r square h. So the new volume will be half the original volume. So the given statement is false. The given statement says the volume will remain unchanged. So this is false. Okay. Next question. In a right circular cone, the height, radius and slant height do not always be sides of a right triangle. Is it true or false? Let's see. If you see this right circular cone, you will find that on rotating this right angled triangular lamina, okay, this, if you rotate this triangle AOB about OA, this is the axis. So if you rotate this triangle about this axis, it generates a cone, right? Point A is the vertex of the cone. Now its base is a circle with center O and radius OB. Length OA is the height of the cone and AB is the slant height. Now this height H is always perpendicular to the radius R, correct? This is the slant height. So now this is clearly 90 degrees and so we can apply Pythagoras theorem. So here this one L square will be equal to H square plus R square. L will be equal to square root of h square plus r square. Now we can see the height, radius and slant height will have to be always sides of a right triangle. They are always the sides of a right triangle. So the given statement is false. Next question. If the radius of a cylinder is doubled and its curved surface area is not changed, the height must be half. We have to check whether this statement is true or false. Let's see. Now we know curved surface area of a cylinder, that is CSA, is 2 pi RH, right? Where R is the radius and H is the height of the cylinder. Now this has to remain the same. So 2 pi RH has to remain as 2 pi RH. But the radius is doubled. So instead of R, it will be 2R. Now to maintain this, shall we divide the height by 2? In that case, what happens? This 2 gets cancelled. So we have 2 pi RH. Correct. So the curved surface area is not changed. Hence, statement is true. That is, the height must be halved so that when the radius is doubled, the curved surface area will not change. So the statement is true. Next question. The volume of the largest right circular cone that can be fitted in a cube whose edge is 2r equals the volume of a hemisphere of radius r. Let's see whether this is true or false. Let's say this is the right circular cone that can be fitted in a cube whose edge is 2r. So this is 2r and that's the largest right circular cone that can be fitted in that cube. Now, if this is 2r, this is 2r, means the radius of the cone will be r and the height of the cone, that will be equal to 2r, because the length, breadth and height of the cube is 2r. So the height of the cone is equal to height of the cube, which is equal to 2r, right? So edge of the cube equals 2r implies height of the cone is 2r. And we already know the radius of the cone is equal to r. So the volume of the cone, which is equal to 1 by 3 pi r square h, will be equal to 1 upon 3 pi r square h will be equal to 2r. Correct? Now, that is equal to 2 upon 3 pi r cube. This 2 upon 3 pi r cube is indeed equal to the volume of a hemisphere of radius r. So, the given statement is true. Next question. A cylinder and a right circular cone are having the same base and same height. The volume of the cylinder is 3 times the volume of the cone. This is pretty simple. You know, the volume of a cylinder will be pi r square h and the volume of a cone will be equal to 1 upon 3 pi r square h, provided they are having the same base. Same base means same radius and same height. So obviously the volume of the cylinder is 3 times this, because 3 into 1 by 3 pi r square h will be equal to pi r square h. So the given statement is true. Next question. A cone, a hemisphere and a cylinder stand on equal bases and have the same height. The ratio of their volumes is 1:2:3. Let's check if this statement is true. Now they have given that the cone, the hemisphere and the cylinder stand on equal bases. So let the radius in each case be r. Now the volume of hemisphere will be equal to 2 upon 3 pi r cube. Okay. Now the cone, the hemisphere and the cylinder all are having equal radius, that is r. Now look at this hemisphere. If this is r, then this also has to be r. Now if this is r, this is the height. If this is r, then as all the three are having the same height, the cone, the hemisphere and the cylinder are having the same height. So if this is r, this is also r. So this height, the height of the cone will also be equal to r. Correct? So the volume of the cone will be 1 upon 3 pi r square h. In this case, it will be 1 upon 3 pi r square into r, right? Which is equal to 1 upon 3 pi r cube. Also, we know the volume of the cylinder will be equal to pi r square h. In this case, it will be pi r square into r, which is equal to pi r cube. Now, check these three. So, the volume of the cone, the volume of the hemisphere and the volume of the cylinder. So, the volume of the cone 1 upon 3 pi r cube, volume of the hemisphere 2 upon 3 pi r cube, and the volume of the cylinder pi r cube. So, we can see that the ratio of their volumes, like volume of cone is to volume of hemisphere is to volume of cylinder will be 1 upon 3 pi r cube is to 2 upon 3 pi r cube is to pi r cube. Pi r cube is nothing but 3 by 3 pi r cube. So, you can see 1 upon 3, 2 upon 3, 3 upon 3. So, indeed, the ratio of their volumes is equal to 1 is to 2 is to 3. 1 is to 2 is to 3. So, the given statement is true. Next question. If the length of the diagonal of a cube is 6 root 3 centimeters, then the length of the edge of the cube is 3 centimeters. This is pretty simple. Now, you know, if the length of the edge of a cube is a, then the diagonal will be a root 3, correct? Now, if the diagonal is 6 root 3, then obviously the length of the edge will be 6 centimeters, not 3 centimeters. So, the given statement is false. Next question. If a sphere is inscribed in a cube, then the ratio of the volume of the cube to the volume of the sphere will be 6 is to pi. Let's see if this is true. Let the side length of the cube be a, then the volume of the cube will be equal to a cube. Now, radius of the sphere will be equal to, if this is a, the radius of the sphere will be equal to a by 2, correct? So, the volume of the sphere will be equal to 4 upon 3 pi a by 2 whole cube, correct? So, volume of the sphere is 4 upon 3 pi of a by 2 the whole cube. So, 4 upon 3 pi a cube upon 8. 4 and 8 get cancelled. So, 4 2s are 8, 3 into 2 6. So, this is pi a cube upon 6. Now, let V1 be the volume of the cube and V2 be the volume of the sphere. So, the ratio will be a cube upon pi into a cube upon 6, which gives us 6 upon pi, or 6 is to pi. So, the given statement that the ratio of the volume of the cube to the volume of the sphere will be 6 is to pi is correct, true. Next question. If the radius of a cylinder is doubled and height is halved, the volume will be doubled. Now, this is pretty simple. We know that the volume of a cylinder is pi r square h. Okay, so let the original volume be V1, which is equal to pi r square h. Now, they say that the radius is doubled. So, let the new radius be twice the old radius, and then height is half. So, the new height will be half the old height. In that case, the new volume will be equal to pi 2r the whole square into h upon 2, correct? So, in that case, this equals pi into 4r square into h upon 2, correct? So, 2 and 4 get cancelled. This is pi into 2r square into h, which is nothing but 2 pi r square h. So, the new volume will be equal to 2 pi r square h. So, they say that the volume will be doubled, and it is indeed true. So, the volume is doubled. It was previously pi r square h, now it is 2 pi r square h. So, the statement is true.